Hello students, how are you? So I welcome you all in this session. So here we are going to discuss about the AIT 6 JEE main physics paper. So in this session we will describe we have selected some problems from AIT 6 paper, and we will find that a little tough, and I have recorded for you. Okay. So we are going to solve them one by one and see the solution of them. Okay. So let's just get started. Now, the very first question on your screen is, if 2t is equals to ax minus bx square, where a and b are constant, the acceleration is. So we are going to solve it. Now, we know that here the relation of position and time is given. So if you differentiate this position with respect to time, you will have velocity. And then again, if you will differentiate it with respect to time, you will have acceleration. So we have to differentiate this expression two times with respect to time also. Okay. So here we have 2t is equals to ax minus bx square. If you differentiate it with, it will become 2 a dx by dt, differentiation of x, minus b is a constant, differentiation of 2x will become 2x dx by dt. Now dx by dt is nothing but the velocity. So a into v minus 2b x into v. You will easily find out the expression of v. It is 2 upon a minus 2b x. Now, if you differentiate this velocity expression with respect to time, you will have the acceleration, which is equals to d by dt of 2 upon a minus 2bx. Now, this function seems to you 1 by x type. And differentiation of 1 by x is minus 1 upon x square. Now, same we are going to follow. 2 is the constant, so it will become minus 1 upon x square. And in the place of x, we have a minus 2bx whole square. But this is also a function itself, a minus 2bx. This will also be differentiable with the chain differentiation rule. We have to multiply with the differentiation of this function, which is minus 2b dx by dt. Now, this will result in 2 into minus and minus will become plus 2 into 2b dx by dt will become v upon a minus 2bx whole square. Now, we know that 2 upon a minus 2bx is v, and here you will see in the numerator it will form 2 square, and denominator a minus 2bx whole square. So it will become pv 2 upon a minus 2bx whole square. Now this will result in bv into v square, which is bv cube. Now option C is the correct option. I hope you got it. Next question. The velocity time graph for particle A and B is given as. Okay. So their relative velocity of A with respect to B is until two curves graph meet again is, first option is 0, second is decreasing then increasing, C is decreasing at an increasing rate, and D is increasing then decreasing. Now, we know that this is the VT curve which is given to us. Now, the slope of VT curve dV by dt gives you acceleration. Okay. So if you differentiate or if you find out the slope of these lines, so line A has a constant slope. Constant slope means it has a constant value of acceleration. Constant acceleration it is. Okay. But if you talk about line B, it has variable slope because here it is in this direction. At this point, if you draw the tangent, it will vary. In this point, it will vary. So the slope of this curve, curve B, is varying in nature, which means a variable slope you have will result in variable or non-constant, you can say, variable acceleration or not uniform acceleration, you can say. Okay. Now, and it is positive or increasing, which means B is accelerating with an increasing rate. Okay, the acceleration is also increasing with a variable rate. So it results the velocity to be increasing. Now, what has been asked in the question? Velocity of A with respect to B, which is given by VA minus VB. Now, VA has a constant slope of increment, which means VA is following the equation of uniform motion. If you write the VA, it will be written as UA plus A into T, A of A into T. But line B is not following any kind of equation, uniform motion of equation because it is varying in nature. Okay. So at some point of time, before they meet, if you will see, they have started from rest, which means the initial velocity of both will be zero, and then they have accelerated. Now, this velocity is dependent on the variable acceleration which is variable. So what will happen? This value of VB will exceed the value of VA because it is varying, but at a constant rate. It is varying, but at a variable rate, and that variable rate is increasing in nature, which means the velocity until they meet, because when they meet, the velocity will become same at that point for both of them. So until they meet, this will constantly reducing the velocity. Sorry, this will reducing the velocity with an increasing rate. Okay. So the total velocity will also decrease. But at which rate? At a constant rate or decreasing? It is as a increasing rate because this is a variable acceleration which is increasing. Got it? So option C is the correct option. This entire velocity, relative velocity of A with respect to B is decreasing, but at an increasing rate. Okay. Now, next question. The trajectory of two projectiles as shown in figure. Projectile 1 has a smaller range and projectile 2 has a larger range. Now, let T1 and T2 be the time of flight and U1 and U2 be their initial speed of projection. Now, for the two projectiles, we can conclude that. Now, in the situation, if you will see, the maximum height covered by both the projectile is same. You can say that H1 is equals to H2. Okay. H1 we can write as U1 square sine square theta 1 divided by 2g, and it will become U2 sine square theta 2 square divided by 2g. Now this U sine theta 1 is nothing but the component of vertical velocity, the component of velocity in vertical direction of 1. If velocity of 1 is U1 and velocity of 2 is U2. So these are the vertical components of 1, and now you will see that if vertical velocities are same, If vertical velocities are same, then what do we conclude? That their vertical velocities are same, but their range are different. So we know that the horizontal velocity of 1 and horizontal velocity of 2. In horizontal direction, there is no acceleration. So these are constant velocities. So if 2 is covering more range than 1 in same time, then what we can say? That ux1 is definitely less than ux2, which we can say that velocity in horizontal direction of 1 is less than velocity in horizontal direction of 2. Okay. Now, if the total velocity u1 is given by ux1 plus uy1 and u2 is given by ux2 plus uy2, then what we can say? ux1 is less than ux2 and u1, uy1 and uy2 same. Same as if I say that y1 is equals to x1 plus 2, y2 is equals to x2 plus 2. Now it will depend on the value of x1 and x2 that which expression is greater. So if x1 is greater, y1 will be greater. If x2 is greater, then y2 will be greater. Now in this expression, ux2 is greater than u1, ux1. So we can say that u2 is greater than u1. Option C is the correct option. U1 is not equals to U2. Time travel is also not equals to, is not unequals. Okay. Now, next question. A ball of mass 1 kg is at rest in position P by means of two light string OP and RP. This is OP and this is RP. The string RP is now cut and ball swing to the position Q. If theta is equals to 45, find the tension in the string in position OP when RP was not cut and OQ when RP was cut. So in this situation, this is the, or let's say, this is string 1, this is string 2 that we have held on a vertical support. Now, this is the ball we have and it is RP and this is, when it is RP is being cut, it will be here at Q, and this angle, half of the angle is 45, this angle is also 45 because this is theta and this is theta given in the question. Now, mass of the ball is given as 1 kg. Okay. And gravitational acceleration is, so initially when RP was not cut, the ball will be here and the weight of the ball will act downward, which is mg. So there will be a development of tension in RP, let's say T1, and here in this string will be T2 because string are different, so different tension will be there. Now we can apply the Lamy theorem here. Apply because it is an equilibrium and these three forces are concurrent in nature. So applying Lamy's theorem. Lamy theorem says that if there are three forces F1, F2 and F3, and the angle between them is alpha, beta, and gamma, then and they are concurrent at a point. So we can say that according to Lamy theorem, it is F1 by the angle between the opposite two vectors. So the angle between opposite two vectors is beta. F1 upon sine beta is equals to similar process for F2. We will have take F2. So angle between F1 and F3 we will take sine gamma F3 over sine alpha. This will result in a constant. Now in this situation, what do we have? We have T1 here, T2 will be here, and mg will be here. Now definitely this angle would be 90 degree. Now what about this angle? We know that if this angle is 45, this angle will be definitely 45. Okay. So this is a formation of Z. If this is 45, this angle would be 45. Okay. If you draw a perpendicular, this angle also would be 45 plus 90. So this total angle will become 135. And this is also 90 plus, because we have to find the angle between two vectors T2 and mg. So it will also become 135. Now applying the Lamy theorem, so we have T1 divided by the angle between two opposite vectors. So we have to take the angle between T2 and mg, which is sine of 135. Sine 135 is equals to T2 upon the angle between other two vectors sine 90 is equals to mg upon angle between another two vector, which is sine 135. Now you can see that T1 is equals to, you can take this pair. So T1 upon sine 135 is equals to mg upon sine 135. This will cancel out. So T1 you will have as mg, and m you have as 1 kg, g you have as 10, so it will become 10 Newton. Okay. Now T2, the same procedure you will follow. Take this and this pair. So T2 you will have as T2 is equals to sine 90 will become 1. So it will be mg upon sine 135. Sine 135 is equals to mg over, it is nothing but 180 minus 45. So it will become sine 45, which is 1 by root 2. Then T2 will become here mg into root 2, and mg is nothing but 10. So it will become 10 root 2 Newton. Now this is the value when RP is not cut. Now if the RP has been cut, what will happen? Now this is the initial position of RP, let's say, and ball will move from here to here at an angle of from here to here. This is angle 45. This angle is also 45. Here is the ball. Now at this position, what is the tension in this? OQ. Same string. Now let us assume the tension in that case is T. We have assumed that T1 and T2 in the previous case. So let us assume the tension here is T. Now the weight is acting downward, mg. Okay, this is the extreme position, which means this bob is now for momentarily rest. Okay, because at extreme position it will came into rest, but for a moment. So for that moment we can apply the equilibrium condition. So we can say that if we divide this mg into two components, This is angle, this angle is 45 from normal. So this angle will also be 45. So we have two component, which is mg sine 45, mg cos 45. Now for equilibrium in radial direction, equilibrium in radial direction, we can say that T is equals to, because there is no movement happening in this direction, so we can say that T is equals to mg cos 45. And mg cos 45 is nothing but 1 by root 2. Mg is 10. So 10 into 1 by root 2 will become 10 by root 2. So this is the stress in this string after RP has been cut. And this T2 is the stress when RP has not been cut. So it is 10 root 2 Newton and 10 by root 2 Newton respectively. Option A is the correct one. A point mass M slides on a frictionless hemisphere of radius R. At what height the mass will set detached? Okay. So very conceptual question from work energy and power chapter. So firstly, we will know the concept. When this mass detach, which means it separate from this hemisphere, so what will happen? The contact between them will be loose. So there is no contact at that point. If there is no contact, so there will be no normal reaction. So N is have to put to be 0. Noted. And another thing that all, if you take it as a system, then all the forces will become internal forces. So we can apply the conservation of energy also. Now, this is the hemisphere you have. Suppose here the mass after this will detach. So this is the last contact position with hemisphere. Now, the radius is given as R. This is the radius, let's say. And let's say the height from where it has been detached is small h. Okay. So this length also would be what? It is also R. So if you say this angle is theta, got it? So the weight of this block will act downward direction, which is, I am writing H here, and the component of force is mg. If this angle is theta, this angle would become 90 minus theta, this angle would become theta. So we can say that the component of mg in radial direction is mg cos theta, and the component of mg in tangential direction is mg sine theta. This is the tangential direction. Okay. And there is a normal reaction in radial direction. So we are applying for at detachment position, yeah, at detached position, at detached position, Fr is equals to MAR, because this normal force is acting in radial direction. That is why we are applying the Newton laws of motion in radial direction. So Fr is the force, which we will say mg cos theta. The direction of centripetal acceleration is inward. So mg cos theta will be taken positive, minus n is equals to m into AR, which is V square upon R. R is the radius. V square upon, let's say V is the velocity at detachment. Now, This N at detachment will become 0 when there is no attachment, there is no contact. When the this block will lose the contact with hemisphere, so there is no contact force, there will be no normal reaction. So mg cos theta is equals to mv square upon small r. This is equation number 1. Now applying kinetic or mechanical energy conservation. Mechanical energy conservation. It is written as kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. Now, this is the hemisphere, let's say. Just a second. Okay. Here the detachment had been happen. This height is h. Okay. And initially the block will start from here. Let's say at rest. But the reference line for potential energy we have taken this. This is the reference line. So initial kinetic energy is 0 plus final. If I talk about the initial potential energy, the mass of this block is m, so it will be mgh, and h is nothing but mgr is equals to the final kinetic energy. Let's say at this point of time the velocity is v, 1 by 2 mv square, plus final potential energy will be mgh. Now we have to find out h in terms of cos theta. This angle is theta. This angle is r. So we can say that component of r, because this angle is also theta, so we can say that if you take the component of r in this direction, so r cos theta is equals to h. So you can put this here. Now mgr is equals to 1 by 2 times mv square plus mg r cos of theta. Take this on LHS and take the mgr as common. So mgr as common, 1 minus cos theta is equals to 1 by 2 mv square. Now v square we have already calculated. mv square upon r we have already calculated. So we can put it as mgr cos of theta, the value of mv square. And this r will take, let's say, this is given in small letter. We are assuming in it capital letter. Don't worry about that. Now, mgr 1 minus cos theta, this will become 1 by 2. Value of mv square will become mgr cos theta. Cos theta. Now, this mgr and mgr will cancel out. It will become 2 minus 2 cos of theta is equals to cos theta. Okay, these two have been multiplied here. So 3 cos theta is equals to 2. Cos theta will become 2 by 3. Now, if you put the value of cos theta in this expression, so h is nothing but r cos theta. So you have 2r upon 3. So h is nothing but 2 small r upon 3, because we have replaced the capital R by small r. So do not worry about that. So 2r by 3 is the correct option. Now, a next question is that a toy gun uses a spring of force constant capital P. Before being triggered in the upward direction, the spring is compressed by a distance x. If the mass of the shot is m, on being triggered, it will go up to a maximum height of. So this is a question from work energy and power. So here you have, let's say, a toy gun, and you have a shot inside that. But in this, you have a spring. It have a spring constant key. So when it is compressed, which means we are doing some work by the trigger. So this work has been stored in terms of spring potential energy, spring potential energy. Okay. And then this potential energy will decrease in terms of gaining the kinetic energy. But after some time, it will achieve the maximum height h and become, this is, let's say, h, and here the velocity will become 0. So if you apply the conservation of mechanical energy here, conservation of mechanical energy, then in this system, the gravity force will become internal force. Okay. So initial kinetic energy plus initial potential energy, initial final energy plus, final kinetic energy plus final potential energy. So initially, when it is compressing the spring, the speed will be negligible. So kinetic energy initial will be 0. But the initial potential energy at the time of release, when it is compressed by a distance x, so it will become 1 by 2 kx square equals to final kinetic energy at the point of maximum height will also be 0, because at maximum height velocity is 0. So final also 0. But the final potential energy is now not the spring, but the gravitational potential energy, which is mg into h. H is h max. So we can say that h max is nothing but kx square upon 2mg. So this is the simple question. This option C is the correct option. Now, the ring is hinged at a point A, and if it is made to fall from the rest, then find the speed of the point B after it has rotated by an angle 30. Okay. So this ring is hinged by this support. Okay. And this wall is like this. And the ring is hinged like this. So ring can rotate about this axis. So it will rotate about this axis. Okay. So for that, what you are going to do, you need to find out the moment of inertia about this axis, because you are going to apply the parallel axis theorem. So for that, you need a diametral axis moment of inertia. We know that the moment of inertia about the diametral axis of a ring is half mr square. Okay. So initially the ring was like this, and finally it has been rotated at an angle by this point at an angle 80 degree. So we can say that if you look at this point, it will look like you. This is the ring from the side view, and it has rotated at an angle 30 degree, which means the center of mass of this ring has also been rotated by an angle of 30 degree. This is center of mass. Now, the weight of this ring is acting on the center of mass. Now, we have to find out the speed of point B after it has been rotated by 30 degree. So how do we find out the speed? For that, we know that torque is equals to I alpha. Okay. So this equation we are going to follow. So we know that the radius vector is also rotated by an angle 30 degree. Initially the radius was like this, and finally the radius has been here. Okay. So mg force is the only responsible force which is rotating this ring. You can apply this mg into r by 2. Sorry, r is equals to I, which is I center of mass about diametral axis plus mass of the ring multiplied by the distance. So we know that moment of inertia about center of mass about diametral axis is half mr square. Now we know that it is mg r is equals to into alpha. So I center of mass is mr square plus half mr square plus mr square. Okay, into alpha. So mgr is equals to 3 by 2 times mr square alpha. Okay. From here, you can cancel out this m and the r. So alpha, what do you have as? Alpha is nothing but 2g by 2g by 3. 2 by 3 will be inverse of it. 3. 2g by 3 into 1 of the power of this radius, which is r. And radius is given to you as 15 meter. Now, the alpha that you have is equals to 2g upon 3r. Now we will put the value of g and r. This is g and this is r. R is given you as 15 meter. G you will take as 10 meter per second square. So alpha is 2 into 10, 3 into 15. 5 to the 10, 5 3 the 15. So it will become alpha is equals to 4 upon 9. Okay. Now this alpha is a constant value, so we can apply the equation of rotational motion, which is omega square is equals to omega naught square, omega naught the initial velocity, plus 2 alpha into theta. Now theta we already know, it is 30 degree. So omega square is equals to initial velocity is 0, 2 into alpha is 4 upon 9 into theta. How much angle it has been rotated? It has been rotated by an angle of pi by 6, because pi by 6 is the 30 degree. So omega here is equals to, this will become 2 3 the 6. So it is 2 by 3, sorry, 4 upon 9 into 3 into pi. So alpha we have put as this 2g by 3. Okay. The dimension of alpha will be second minus 2, because omega has a dimension of second inverse. So this is, we have 4 pi into 27 radian per second, and it is radian per second square. Okay, so this is the answer we have got. But here nothing matches with this answer. So option D is the correct option. Okay. Now, a uniform road is hanging if the mass per unit length is lambda, length is capital L, and Young's modulus of the road is Y, then the elongation will be. Very good question. And from the mechanical properties of solid, it can also be described as the elongation in rod due to self-weight. So what do we have? We have a rod of length L, let's say capital L, okay? And mass per unit length, which is the linear mass density, is given by lambda, okay? So we need to find out the elongation in the rod. So in rod, the weight will be acting downward direction, weight of the rod, due to which the rod will elongate. Okay. So we will consider a section at a distance x, from the bottom. We will consider a section of distance dx, and we will assume that this ds section will elongate dl. This is the small elongation that we have. Now, this dx section will be pulled by this section, which is having a length of x. Now, what is the mass of this? Because the weight of this section will pull this dx section. So it will become m dash. We know that m dash is nothing but lambda into the length. Lambda is m upon L into x. Now this is the mass. So what will be weight? Weight is m dash into g. So it will become mx upon L into g. This is the load, let's say W dash, which is elongating this element with the length of dl. Now we know that elongation is given by load applied multiply by the original length. Original length of this section is dx divided by y into a. Y is the Young's modulus. A is the what? A is area of cross section. Now dl is equals to W dash. Put the value of W dash. It is m dash into g, and m dash is lambda x. So lambda x into g, because in answer only lambda terms you will see. So we will take this m dash in terms of lambda. So lambda xg dx divided by y into a. Now this lambda g, y and a are the constant. So we will integrate it from 0 to L, because x varies from bottom to the length of the road, full length of the road. So it is lambda g upon ya 0 to L x dx. This dl will become delta L, the complete elongation, the entire elongation in the length. It will be lambda g upon ya. This will become integration of x dx is x square by 2, and put the limit L to 0, it will give you L square by 2. So it is lambda g L square upon 2ay. Okay. So option B is the correct option. So we have to consider a section from bottom L, and this bottom section will apply the load to this section, not the upper part. Okay. Now, this question is from mechanical properties of fluid, or generally we will say it fluid mechanics, and a very important question, very conceptual question. So a uniform rod of length 2 meter, specific gravity 0.5, mass 2 kg is hinged at one end to the bottom of the tank of water, specific gravity 1, which is of water. filled up to a height of 1 meter as shown in figure. Now, taking a case when theta is not equals to 0, the force exerted by the hinge on the rod is. So now we will assume that, and it is also somehow given in the question, that this rod is in equilibrium. Okay. So portion of this rod which is inside it is this. So we will draw it here. So this is the rod which is inside the water. Okay. Now this height is 1 meter. This angle is given you as theta. Now, if you see the component of this length, let's say this length is L dash. The component of this length in this direction is L cos theta, and L cos theta, L dash cos theta is given you as 1 meter. So L dash cos theta given you as 1 meter. So what is the value of L dash? L dash is 1 upon cos theta. So the length that we have here is L dash. Now we will consider this is point A, this is point B, and this is point C, and this is a point D, which is just half of the this length AC. Now we know that the weight of this rod will act downward, acting at the center of mass. Center of mass of this rod will be at the half of the distance. So this is the weight of the rod which is acting downward. Now there is another force in this system that will act, which is the force provided by the fluid. And here fluid is water. So water will also apply a force on exactly at the half of the length which is immersed in water. And that force is buoyant force, which act exactly at the center of length immersed, not the complete length, the length which is immersed in the water. Okay. So we know that FB is buoyant force is density of liquid multiply volume immersed of the body multiply by gravity. Now we will calculate the FB for it. FB is nothing but density of liquid. Here in this question, if you will say specific gravity is given to you, we know that specific gravity is nothing but density of the material divided by density of water. So if you talk about the density of liquid, which is water, so we know the value, it is 1000 kilogram per meter cube multiply. Now volume immersed, this is important. We know that nothing is talk about the area of this, only length is given, and which is 2 meter. Okay. So we want to know, because specific gravity of this rod is given, which is we can calculate the density. So the density of rod is nothing but specific gravity into 1000. Specific gravity is 0.5 into 1000. So density of rod is 500 kilogram per meter cube. Okay. Now, how do we use it for volume immersed? Now we know that volume immersed will be density of rod into density of rod into mass. Can we say that? No, because density is given by mass upon volume, and we are interested in volume. So volume immersed will be mass immersed, which is inside the liquid, divided by density of the rod. Now, to this entire length L, 2 meter, the whole mass capital M is distributed, which is 2 kg. Let's say we will assume it as L. So for capital L length, the mass which is distributed is capital M. So for 1 unit length, the mass distributed is m by n. And 4, the desired length, let's say for x length, it is m upon L into x. Now, the length which is immersed inside the liquid is 1 by cos theta. Okay. So we will do it on next page. Or here we are going to do. So mass immersed is total mass divided by total length multiplied by the length which is immersed. So it is L dash, and L dash is given by 1 upon cos theta. Now mass is given you as 2, length is also given in 2 meter, mass is given 2 kg, 1 upon cos theta. So this will become sec theta. Now volume immersed is nothing but mass immersed divided by density of the rod. Mass immersed is sec theta divided by density of rod. We have calculated as 500. So we will put all these value, volume immersed, gravity and density of the liquid in equation number 1. Then what do we have as buoyant force is equals to density of the liquid, volume immersed, gravity. Density of the liquid is 1000. Volume immersed we have calculated as sec theta divided by 500 multiplied by 10. So buoyant force you will have as what? 20 sec theta. This is equation number 1. Now, for rotational equilibrium, the moment of this force, which is weight, and moment of buoyant force about hinge will be 0, because if the rod is not rotating as in equilibrium, so it can only rotate about this hinge end, and this is not rotating now. So moment of these forces will be cancelling out each other. Okay. FB will be acting at a distance of, we will take the perpendicular distance. So we have to take L dash sine theta. Okay. This perpendicular distance is L dash sine theta on which FB is acting. And W is acting on this. You can take L dash cos theta. L dash by 2 in the case of buoyant. I will discuss it on the so here is the rod. This is the rod. From here, it is immersed in the liquid. Okay. This angle is theta. So this length is, entire length is L dash here, which is inside the liquid. Okay. So buoyant force will act at the middle portion of the inside length. This is FB. It is acting at L dash by 2. But for moment, you have to take the perpendicular distance to force. So perpendicular distance will be L dash by 2 sine theta. And this weight is acting downward, and perpendicular is distance is this. And this is L dash sine theta because it is acting at L dash. So L dash sine theta. Got it? Now, or you can say that this weight will act exactly at the half of this rod. Okay. So the moment about this point O, moment about point O is FB into L dash by 2 sine theta minus, why I'm taking minus? Because it is in opposite direction of it. So I have taken clockwise direction negative and anti-clockwise direction positive. So this is the clockwise direction, which is mg. Now mg will acting at L by 2, but I have to take the perpendicular distance. So it will be L by 2 sine theta is equals to mg into L by 2 sine theta. Okay. Now sine theta and sine theta will cancel out. So FB you will calculate it as 20 sec theta into L dash by 2. We will calculate the value of L dash by 2, which is L dash is 1 by cos theta. So L dash by 2 is 1 upon 2 cos theta. So 1 upon 2 cos theta equals to mg into L by 2. Now this 2 will cancel out this 20. 10 1 upon cos theta will also become sec theta. So it will become sec square theta. Mass of the rod is given you as 2 kg into 10. Length of the rod is 2 divided by 2. 2 and 2 will cancel out. This 10 will cancel out this 10. So you have sec theta is equals to root 2. The value of sec theta is root 2 for theta is equals to 45. Now, for vertical equilibrium, what will happen? This weight should be equals to this FB. Okay. So from here, theta is 45. So you can calculate FB. So FB is nothing but 20 into root 2 Newton. Got it? For this rod to be in vertical equilibrium, for vertical equilibrium, because there are two possibilities, either this rod can rotate or fall. So this is for the vertical equilibrium. The forces are balanced. We have to equate these forces. FB is equals to mg. Okay. Got it? Now, in this situation, if you will see, the force exerted by the hinge on the rod has been asked. So there is a, on the rod, there is a force of buoyancy and there is weight. So sum of these forces, the net force, the net resultant from force from this buoyant force and weight will be countered by this hinge. This is the force by hinge. Got it? So force by hinge is nothing but weight minus buoyancy. Weight force is 20 Newton because 2 kg is weight multiplied by gravitation acceleration, which is 10. So it will become 20 minus FB. You have already calculated it is 20 root 2. So if you calculate the value, it will come out to be 8.29 Newton. Okay. And this force will act in down upward direction because the net resultant force came in downward direction. So the hinge will apply a equal and opposite force in upward direction. So 8.3 Newton downward direction force will be there. Okay. This is the force exerted by the hinge on the rod. Got it? Now, a solid body rotates with deceleration about stationary axis with an angular deceleration alpha. That is deceleration. So be careful with the statement of the question. So alpha you given as k into root omega, where k is a constant, omega is the angular velocity of the body. If the initial velocity of the body is omega naught, then mean angular velocity of the body arranged convert the time of rotation is, which means it is a deceleration. So when body is rotating, it will deaccelerating, which means at a point of time, the rotational speed of this body will become zero and then will again rotate in the opposite sense. So for that time to that time, when the velocity will become zero, we have to find out the mean angular velocity. Now we know that alpha is nothing but alpha is given you as k root omega. Now alpha you can take minus dv by dt because it is a deceleration. So k root omega, and you will take at d omega by dt. Okay. So minus d omega by root omega is equals to k dt. Now we will integrate it. Okay. We will integrate it for 0 to at time t equals to 0. The velocity is omega naught at initial time. So it will be omega naught. And let's say at time t naught, this will become 0. Okay. So we know that integration of 1 upon root x dx is x raised to the power. This is 1 upon root x. So it is x raised to the power minus half when it comes upside. So you will have as x raised to the power plus half divided by half. So it is automatically will become 2 times root x. Okay. So now, or we will calculate it for, let's say, for a general time t. For a general time, the omega will be here. So we will say that it is minus root 2 root omega 2 root omega naught to omega is equals to 0 to t k dt. It will become k into t. Now put the limit. So it will become minus 2, you can take common out. So it is root omega minus root omega naught. Okay. Equals to k into t. Now this 2 you can multiply in this side. So this is root omega is equals to root omega naught plus, sorry, minus 1 by 2 times k into. If you take the square of it, it will become omega is equals to root omega naught minus 1 by 2 times kt whole square. Okay. If you find out the time where this omega will become 0, because we have to calculate it for that time when the rotational will change. Rotation will change. So omega will definitely be 0 for that time. So put this omega 0 here. For change of rotation, put this omega is 0. So you will have 0 is equals to root omega naught minus 1 by 2 kt. This square will also vanish. So this time is, let's say, t naught. So t naught is the time which is equals to 2 root omega naught divided by k. So for this time, the velocity will change its value. Okay. Now, we have to calculate the average value of the angular velocity for that time. So average velocity will be given by V average is given by integration of omega dt divided by integration of dt. Now for what time we are calculating it? We are calculating from 0 to t naught. So it will also from 0 to t. So omega average is equals to omega average is equals to integration of omega, and the expression of omega we have as root omega minus 1 by 2 kt whole square. It is root omega minus 1 by 2 kt whole square dt 0 to t naught, and this will become t naught because it is the simple integration. Now you will open the square of it, 0 to t naught omega root omega, it is root omega naught, sorry. So root omega naught, square of this will become omega naught plus 1 by 4 kt whole square, and 1 by 2 square is 4, minus 2 into root omega naught into 1 by 2 times k into t. Okay, dt divided by t naught. Now you distribute the integration, so it will become 0 to t naught omega naught into dt plus 1 by 4 k 0 to t naught t square into dt minus this 2 and 2 will cancel out, so it will become integration of, and root omega is a constant and k is also constant, so root omega naught k integration 0 to t naught into t dt. Got it? Yeah, divided by t naught. Now this will become omega naught into, this is t naught, omega naught into t naught, integration dt will become t, and limit of t is 0 to t naught, so it will be t naught plus 1 by 4 k into t naught by 3, t naught cube by 3 minus root omega naught k into t naught square by divided by t naught. So if you divide this expression by t naught, one of the power will be cancelled out. So it will become omega naught plus 1 by 4 times k into t naught square, and this will become 1 by 12, 4 into 3, t naught square plus, sorry, minus you will have, okay, minus root omega naught into k into t naught by, now this is omega naught plus 1 by 12 k, put the value of t naught, so t naught is nothing but 2 root omega naught divided by k. Let me check, 2 root omega naught by, put the value, so here it will become k, 2 root omega by k whole square will become 4 omega naught by k square into minus, this is root omega k, t naught by 2 will become 2 root omega naught by k. Okay, so here we will missing one thing, it is square of k square and t square, so k square will be there, so here you will have as k square, k square and k square will cancel out, k and k will cancel out, so it will become omega naught plus 1 by 12, or this 4 will cancel out this 12 by 3 times, so it is 1 by 3 omega naught minus root omega, and root omega will become omega into 2, so 2 omega naught. If you take the LCM, this will become 3 omega naught plus omega naught minus 6 omega naught divided by 3. So 3 omega naught plus omega naught will become 4 omega naught, and 4 omega naught minus 6 omega naught will become 2 omega naught by t. minus. So this is the average speed of this. Okay. Now in this, look, if we are making some mistakes, let me recheck it. This is the square of this omega naught plus 1 by 4 k square t square 2 into root omega plus 1 by 2 kt. So 2 and 2 will cancel out. Okay. Got it. Now, so omega naught into t naught here plus 1 by 4 times k square t naught square. T naught square will become t naught cube by 3. So it will become 1 by 12. Okay. Into k square. It will become t naught square by 2. T naught will divide all the things on the upside. It will become omega naught 1 by 12 k square t naught square minus root omega naught into k into t naught by 2. Okay. So here you will have omega naught plus 1 by 12 into 4. So 4 is a 12. But here we have missed 1 by 2. Okay. So this will become 1 by 2. 2 and 2 will cancel out. So what it will become? Sorry for the mistakes. So omega naught and omega naught will cancel out. It will become omega naught by. Okay. So this is the average value of the rotational speed of body. Okay. Now, in this question, a car begins to move at time t is equals to 0 and then accelerate along a straight track with a speed given by Vt is equals to 2t square meter per second for 0 to 2. After the end of acceleration, the car continues to move at a constant speed. A small block initially at rest on the floor of the car begin to slip at t is equals to 1 second and stop slipping at t is equals to 3 seconds. Now find out the value of n if the ratio of coefficient of static and kinetic friction between the block and the floor is n by 3. Now, so this is the car, let's say. You will have this car and this is the block on it. Got it? And this is frictionless. This is a friction surface, rough surface, you will say. This is the rough surface. So initially, this body is accelerating for t is equals to 2 seconds. And v is given by 2t square. So initial speed, if I talk about t is equals to 0, the speed of the block will be 0 and the vehicle will be 0. Okay. After the end of acceleration, and acceleration end at t is equals to 2. So we will calculate the velocity at t is equals to 2. At t is equals to 2, v is equals to 2 into 2 square, which is 8 meter per second. Okay. After the end of acceleration, the car continues to move at constant speed. A small block initially at rest on the floor of the car begin to slip at t is equals to 1 second. Now, if this block starts slipping at 1 second, what is happening before? Before it is not slipping, because if you see, if you are sitting on this floor, so this is a question of non-inertial frame of reference. So there is a friction because there will be a pseudo force on this body, which is mass of this block into acceleration of the vehicle. So this pseudo force will be compensated by or equalized by the friction force. But this friction force has a limiting value. Static friction initially has a limiting value. So at 1 second, it begin to slip, which means at 1 second, this friction will act as a limiting friction. So at that time, at t is equals to 1, friction will be friction will be limiting friction. Okay. So at this time, you can say that you can equalize this with MA. So MA is equals to F. This is the condition for just starting the motion or just slipping. When the slipping is just started. So M into A, mass of the block, into acceleration of the vehicle is equals to F. And F you can write at mu S into N, because limiting value of the friction is the highest value of static friction into mass into acceleration. Now, acceleration you will calculate as dv by dt, which is 4t. So this is the expression for acceleration. Now we are calculating the acceleration at t is equals to 1. So it will be 4 meter per second square at t is equals to 1. So mu s into this is n is equals to mg. This is the normal reaction and this is the weight of the body mg. Now m into m and m will cancel out. So mu s you will have as 4 by 10. Okay. So mu s we have calculated. Now when this body has started the movement, initially it is moving with a speed of 8 meter per second. Initially it is moving with a speed of 8 meter per second, because if you see the motion of this body on ground, now we have shifted our framing ground. So this body is moving with vehicle. Okay. So for that movement, we will see this initially is moving with the same velocity, and the velocity up to what time? Up to t is equals to 1 second, because at 1 second it starts sleeping. So initially the velocity of this block is given by v is equals to 8 meter per second, and finally it will become 0 because of that, because of the kinetic friction. Okay. So we can say that v1 or final velocity at t is equals to 3, because at t is equals to 3 it is coming again at rest. At t is equals to 3 it coming again at rest. So v final is equals to v initial plus acceleration into time. Now this time is not from 1 to 3, it is from t is equals to 1 to, yeah, it is from 1 t is equals to 1 to t is equals to 3 seconds. Got it? Now this acceleration is caused because of the kinetic friction. Now look at the motion of this block. At t is equals to 1 second, it starts slipping, and at 0 to 2 the acceleration is acting, which means acceleration act as up to t is equals to 2 seconds. There is an acceleration. But after t is equals to 2 seconds, there is no acceleration, only deceleration, which is provided by the kinetic friction. This is kinetic friction. So if we apply this equation for time t is equals to 2 to t is equals to 3, so we will have force, which is mu k into n is equals to mass into acceleration. Mu k into n will be again mu k into n, which is mg equals to ma. M and m will cancel out. So acceleration here will become mu k into g, which is a deceleration. So final velocity at c is equals to 3 will become 0. So 0 is equals to initial we will take as 8 meter per second because acceleration at up to 2 second. Okay. And at 2, the velocity is 8 meter per second. Minus mu k into g into time frame will is 1 second. So mu k you will have as you will take mu k into g here. Mu k into g is equals to 8. So mu k you will have as 8 upon 10. Now it is given that we have to find out the ratio of coefficient of static to the kinetic friction. Now, so mu s upon mu k is equals to 4 by 10 into mu k 10 by 8. So here you will have as, okay, just a second, I will write it on the next page. So mu k you have calculated as 8 and mu s you will have as 4. 8 by 10 will become 0.8, it will become 0.4. So it has been asked in the question the ratio of kinetic to the static friction, so which is given by n. Mu k by mu s is equals to 0.8 by 0.4, which is not 0.2, it is, this is the correct option. So this is the last question of this session. I hope you will enjoy this session. Thank you so much for your attention that you will give it to the lecture. Okay. Thank you so much.